Hello, good morning. So today let's continue to talk about the binomial distribution. Binomial distribution. So what anything you know you know about binomial distribution? If there is a random variable x, it follows a binomial distribution. There are two parameters that we need to know. First of all, we need to know how many times of the experiment the child, and for each of the child, what is the probability of success. So these are the two parameters, the important information about the binomial distribution. And there are two things that we could tell from the, not only two things, but, okay, so first of all, the how to find the probability for x equal to, what about a? Then we could use the formula. So first of all, NCA, and then the probability of success, we need A times the probability of failure should be N minus A number of times. So this is the formula for binomial distribution. And also how to find the expected value and also the variance. Do you remember? For binomial distribution, expected value is just n times p, while the variance is equal to n times p, n times one more thing. Guess what? What is that? 1 minus p. Yes, that's right. So there are three things that we need to know about a binomial distribution. So today we'll be looking at some more questions. You need to have some more demonstrations. So we're going to use the questions from the book. All right, so let's start from the level 2 questions. So whenever you are doing this kind of question, the probability distribution, no matter binomial distribution or geometric or Poisson distribution, there is a standard format. So today, let's look at the format. Look at the question, please. Can you see? Do I need to make it bigger? So it is given that the probability for any person to be recovered from a disease is 0.8. So recovered from a disease, the probability is 0.8. And the recovery of any person is independent. So it is nothing. I would like to cross it out. So ignore it. If 15 persons suffer from this disease, there are totally 15 people. Each of them could be recovered or not recovered. Find the probability that 5 of them will recover from the disease. So, this is a very classic question. So we have to find out how many times that we have to check. We have to check 15 times because there are 15 people. And for each of these people, he or she could be recovered or not recovered. So the probability for recovered is 0.8. This is what we defined as success. The probability of success is 0.8. And then we are looking for 5 of them will be recovered, so that we could now set up define the random variable first. For question number 10, we have to define the random variable. Let x be. So let x be what? Number of people We want X to be the number of people we covered amongst how many people? Totally. Amongst 15 people. Yes. So first of all, we have to define the random variable. Let X be the number of people we covered amongst 15 people. And then X will follow a binomial distribution. Okay? 15 people, totally there are 15 people. We have to check 15 times. And for each of them, it could be covered or recovered or not recovered. And we want them to be recovered. This is what we defined as success. So we have to put the probability of success here. It is given to us 0.8. So this is the distribution of X. The first step, you define what does it mean by X. And the second step, you have to tell people what kind of distribution that it follows. And then the last step, what exactly are we looking for? We are looking for the probability that, what is that probability? 5 of them will recover. 5 of these people, we want X equal to 5. Amongst these 15 people, we want 5 people recovered. What is that probability? Okay, so first step, define X, the random variable. The second step, tell people what kind of distribution that it follows. And then finally, what are we looking for? X equal to 5. So according to the formula, because it is binomial, we could use the formula 15C5. And then probability of success 0.8. We need 5 of them recovered, 5 success. What about failure? 1 minus 0.8 is the probability of failure. How many times? 15 minus 5. We need 10 of them. Oh, too sad, not recovered. Okay, so this is how we find this probability. And then, what is that? 0.8 to the power of 5 times 0.2 to the power of 10. And then 15C5 times 15C5. What is that? Okay. So as you can see that this number is very small, something times 10 to the power of negative 0.4. So that if you have if your law of indexes scientific notation is not very strong, you could put it this way. Whenever you see this, you may try to add 1 to the result. Then you will see that the result is, because the 1 is that we just make it up, so you should ignore it. 0.000100764. This is the probability. Okay? And you have to give your answer to 3 significant figures. Oh, how come so small? Let me check. What is the answer? 101. Oh, I see. Not 4 dp. It's 3 significant. 3 significant. So that we start from the first non-zero number 1, 2, 3, and therefore our answer should be 101. Okay, so this is corrected to 3 significant figures. And then, now, let's look at number 11. Oh yes, by the way, it's been a very long time. I cannot hear anything from Aaron. Aaron, are you here? So if you can hear me, please say hi in this group. Aaron and who else? Wicom, Ali, Willis, Logan, Ricky. Okay. Now let's look at the second one. It is given that when a dot, you know what is a dot? This is a dot. So you're going to fold something, and in order to hit at the center, this is a dot. It is given that when a dot is fold at random, the probability for hitting the 1 point region of the dartboard is 0.7. Assume that any fold of a dot is independent. Find the dot. If the dot is fold 10 times, find the expected number of times of hitting 1 point region of the dartboard. So what are we doing? We're going to fold something in order to hit the center, and we are going to do it 10 times. For each of the time, the probability that you can hit the target is 0.7. So this is a binomial distribution. So let's define a random variable. Let's do it here. Okay. So first of all, you have to define let x be. So please think what should be x. Let x be the number of times. The number of times hitting the target, which is what we call 1 point region. Hitting 1 point region. How to spell? G-I-O-N. Okay. Let x be the number of times hitting 1 point region. Amount, how many times? Totally. 10 times. Okay. It is properly defined. Then x follows what kind of distribution? Of course, binomial. But can you tell what are the parameters? First of all, yes, we're going to do this silly thing 10 times. And for each of the time, success means hitting the 1 point region. Right? Do we know this probability hitting the 1 point region? Oh, 0.7 given to us. Alright, so this is the probability distribution. And then, what are we looking for? Look at this. Find the expected number of times hitting 1 point region. Expected number. You have to find expected number of x. Can you do that? Do you know how to find the expected number? Remember this? Expected number of x equal to n times p. So, just 10 times 0.7, which is 7. Okay? This is question number 11. Let's continue. Number 12. Based on the past records, the main printer in a computer center of a